Hey, so in this video, we are going to be learning how to prove the sine and the cosine rule. So proofs are very important to learn, but not also important to learn. They're also very important to understand, because if you understand your proof, you will not have to learn it off. So in the Leaving Cert higher level course, there are multiple proofs that you do have to learn, but two being the cosine rule and the sine rule, which we are proving today. So the cosine rule. How we start this proof is we draw a unit circle with a radius of b. So our unit circle uses a radius of 1. In this case, we are now scaling it up by a factor of b. Now, when you're drawing your circle, you don't need to be taking out your compass and doing anything mad like that. You just need to draw a regular old circle like this. That's good enough, right? So I'm just going to make a note here. The radius equals b. So what you do now is we are going to draw in a triangle. We usually draw in this exact triangle here. So this side, then we draw this side. We kind of extend it out a little bit like so, and then we connect the two sides up. Right? So that's the triangle we need. Next step is we draw in our angle A. So this is angle A, and if that's angle A, therefore this side of this triangle is side A. This side B here is the radius, so we're just going to call that B. And then finally that means this side is equal to C. So I filled in my sides and my angles. Now let's fill in some coordinates that we know. So over here, right, remember it's a unit circle. So I can write the coordinates of a unit circle with cosine of my reference angle and as my x-axis, as my x-coordinate, and sine of my reference angle as my y-coordinate. So I'm going to put this here. So the coordinates for this point are, now the one thing you have to be aware of, we scaled up my unit circle by b. So the units here are going to be b cosine A and b sine A. So that's these coordinates right here. The ones right here on this vertex are just 0, 0, because it's the origin. And then this one here, over here, well, if you see here, the length of this side, it's on the x-axis. The length of this side of the triangle is c. Therefore, the x-axis here is going to be equal to the value c, and the y, not the y-axis, the y-coordinate value is c, and the y-coordinate value will be 0. So you have to reproduce this diagram in your exam, right? Just learn how to draw it, learn them 3 key points, and then we're golden. So what are we trying to prove here? Well, I need to get A on its own. So what we do is, I know, well, the distance from this point to this point equals A. So I say A is going to be equal to the square root of, so we'll use my distance formula. So the distance formula is equal to the square root of x2 minus x1, all to be squared, plus y2 minus y1, all to be squared, and then we square root all of that. So just label your 2 points, so x1, y1, x2, y2. So let's draw it out. So I'm going to have b cosine A minus c squared plus b sine A minus 0 squared. So now I have this. Now the rest should fall into place. So I'm going to square both sides to get rid of A. So it's going to be A squared is equal to b cosine A minus c squared plus b sine A squared. We have 0 there. A squared is going to be equal to, you multiply out this bracket, So it's going to be b cosine A minus c times b cosine A minus c plus, and then squaring this bracket out, that's just going to be b squared and sine squared A. So now we're going to multiply out these brackets here. So b cosine A times b cosine A is b squared cosine squared A. B cosine A minus C is, by minus C, is going to be minus BC cosine A. To see now our formula is starting to take shape. Minus C here, that's going to be minus BC cosine A. And minus C times minus C is plus C squared. And then finally, plus B squared sine squared A. So, is equal to A squared. We are so close now. What I'm going to do is I'm going to gather these two terms here, b squared cosine squared A and b squared sine squared A. So b squared cosine squared A plus b squared sine squared A, then plus c squared minus bc cosine A minus bc cosine A is minus 2bc cosine A. So we're so close to my cosine formula. What I just need to do now here is I just need to factor out a b squared, because they have a b squared in common. Factor that out. And I'm left with cosine squared A plus sine squared A plus c squared minus 2bc cosine A. Now, a rule you just have to remember is cosine squared of an angle plus sine squared of an angle is equal to 1. So all of this bracket is equal to 1. So therefore I'm going to have a squared is equal to b squared times 1, which is b squared, then plus c squared minus 2bc cosine A. And therefore, ding ding ding, we have proven it. So that is the proof of the cosine rule. So it's actually not too bad. You just need to remember to draw your circle, label your size, label the appropriate points, and then the distance formula, and cosine squared plus a cosine squared A plus sine squared A is equal to 1. Right, so that's it for the cosine formula. I hope this video was some help to you guys, and the next video we're going to be going over sine rule. So I'll catch you guys later. Bye.